Hi everybody, we're going to take a look at guided notes for standard 15, parallel lines and transversals. So what exactly is a transversal? If we're going to look at transversals and special angles, we need to know what is this term. So a transversal is a line that intersects two or more coplanar lines. Line that intersects two or more coplanar lines. Coplanar, we've seen that word before, and that just means that they fall within the same plane. So a transversal here would be this line right here, AB, and it's intersecting two or more coplanar lines. Now we're going to do an investigation, and this is going to look at special angle relationships. So our directions tell us to draw our own transversal across the parallel lines L and M, and then we're going to have to label and measure each angle. So L and M are drawn for us, and you can see they are indeed parallel by our two arrows indicated on each line. And we're going to need to use our protractor. So pull out your protractor that you have for geometry. And we need to draw our own transversal. So you can draw your transversal going whichever way you like. I'll draw mine looking something like this. So this would be my transversal. And we need to label our angles here, and I'd like for everybody to label them the same way. So no matter how you drew your transversal, I'd like for you to label your angles like this: 1, 2, 3, 4, 5, 6, 7, 8. So here's us just being consistent in how we label them. That way we can talk about these angles in the same manner. But now you need to measure each angle. So you have 8 angles, and you're going to need to use your protractor to measure all 8 of these angles. So at this time, go ahead, pause the video and see what you come up with for these 8 different angle measures. Here are the angle measurements that I came up with, and I don't expect that you got 105 degrees and 75 degrees because that all depends on how you drew your pink transversal. But I do hope that you noticed a pattern. So the pattern that you should have noticed is that all 8 of your angles were one of 2 angle measures. So in my case, my angles were either 105 degrees or 75 degrees. If this was not the case for you, that all of your angles were one of 2 different angle measures, then you may need to go back with your protractor and double check. Maybe you were not precise enough in the way you used your protractor to measure the angle to the nearest degree, so you may need to look back at that. The other thing I'd like for you to look at right now is look at angles 1 and 2. So angles 1 and 2 form a straight line. So because they form a straight line, they are a linear pair, and they should add to 180 degrees. So you need to double check that the measures that you got for angle 1 and angle 2 add to 180 degrees. So here 105 degrees plus 75 degrees does indeed give me 180 degrees. If for some reason these don't add to 180 degrees, or I could look right here at angles 1 and 3, those are also a linear pair. 105 plus 75 gives me 180. Then you might need to go back with your protractor and double check, because the 2 different angle measures that you came up with, they should add to 180 degrees. Okay, so once you've double checked your angles, again, they don't need to be the same angle measures as mine, but they do need to be 2 different distinct angle measures, and those 2 measures do need to add to 180 degrees. So now that we have drawn our transversal and we've labeled all 8 angles with their corresponding angle measure, let's look at these special angle relationships. So the first one is the corresponding angles postulate, and we're going to need to use our figure to talk about what are corresponding angles. So in my figure, corresponding angles would be like angles 1 and 5, meaning corresponding, meaning they are on the corresponding or same side of my pink transversal. So I'm going to say same side, meaning they're on the same side of my pink transversal. One of them is inside. What do I mean by one inside? This region right here between my two parallel lines, this is what we call the interior, or we could say the inside. This region smushed between my two parallel lines is the interior or the inside, compared to this region outside of my parallel lines. This is the exterior or the outside. Same with here at the bottom. Outside of my two parallel lines, this is the exterior or outside. So corresponding angles postulate, that would be like angles 1 and 5. They are on the same side of my pink transversal. One of them is on the inside region, so that would be like angle 5. The other one is on the outside. One is on the outside region, so that would be like angle 1. And we will make a note that they are non-adjacent. Adjacent meaning next to each other. So they cannot be next to each other. What that means is I can't say 1 and 3 are corresponding angles, because 1 and 3 are adjacent angles. They are next to each other. So angles 1 and 5 right here would be corresponding because they're both to the left of my pink transversal. One of them is in the inside region, one of them is in the outside region, and they are not adjacent or non-adjacent. I can say that angle 1 is congruent to angle 5. Another pair of corresponding angles would be angles 2 and 6. Angle 2 is congruent to angle 6. Another pair would be angles 3 and 7. Angle 3 is congruent to angle 7. And a last corresponding angle pair would be angles 4 and 8. Angle 4 is congruent to angle 8. So I have 4 pairs of corresponding angles from my figure. Next, we can look at alternate interior angles theorem. And alternate, well, that sounds like they now are no longer on the same side of the transversal. Now they're on opposite sides of the transversal. So I'll say that they are on opposite sides. Interior, well, that means they both need to be in my inside interior region. So I'll say both inside. And I'm going to make a note that they are non-adjacent because we're not looking at the angles that are next to each other. So alternate interior angles would be like angles 3 and 6 because they are on opposite sides of my pink transversal. Angle 3 is on the left of my pink transversal. Angle 6 is on the right of my pink transversal. They are both smushed in the interior or the inside of my two parallel lines, and they're not adjacent, so they're not next to each other. So I could say angle 3 is congruent to angle 6. And I do have another pair of alternate interior angles, and that would be angles 4 and 5. Angle 4 is congruent to angle 5. Next up, I can do alternate exterior angles. So I see that word alternate, so that must mean they are on opposite sides of my pink transversal. I see exterior, so they're now, instead of both being inside, they're both going to be outside. They're in that outside exterior region. And I'm going to make a note that they are non-adjacent. So alternate exterior angles would be like angles 1 and 8 because they are on opposite sides of my pink transversal and they are both in the outside region. So I can say angle 1 is congruent to angle 8. And the other pair, instead of looking at 1 and 8, would be angle 2 and angle 7. So I can also say angle 2 is congruent to angle 7. We have one final special angle relationship, and that is same side interior angles. So same side, meaning now they're going to be on the same side of my pink transversal. I see the word interior, so that means they both need to be inside. Both inside. So same side, both inside. So that would be like angles 3 and 5. They're both on the same side of my pink transversal, so they're both to the left of my pink transversal, and they're both on the inside region. The only thing here is, are angles 3 and 5 congruent? No. Angle 3 is 75 degrees in my case, and angle 5 is 105 degrees. So angles 3 and 5 are same side interior angles. However, they are not congruent. There's a different type of relationship between them. And that relationship is that they are supplementary, or they add to 180 degrees. So 105 plus 75 gives me 180. So I could say that the measure of angle 3 plus the measure of angle 5 equals 180 degrees. I do have one other same side interior angles pair, and that would be angles 4 and 6. And again, they are on the same side of my pink transversal. They're both to the right of my pink transversal, and they're both smushed on the inside or the interior of my two parallel lines. And they are also supplementary. So I can say the measure of angle 4 plus the measure of angle 6 is equal to 180 degrees. So it's important to note that for these special angle relationships, corresponding angles, alternate interior angles, and alternate exterior angles are all congruent, but same side interior angles are not congruent. They are supplementary, or their measures add to 180 degrees. All right, so these are the different types of special angles that we will need to know. And if we flip to the back side of our notes now, we can practice using the information we know about these special angles. So the directions say, given that line M is parallel to line N, we are asked to list all the special angles. So I'm going to make a note here. I'm going to put the parallel tick marks. And for me, I always really like to emphasize what is my transversal. So I'm highlighting my transversal here in pink. Transversal. Going to zoom in a little bit. And we can list all of the special angles that we know. So we just learned some new ones, but we did know some special angles previously. For example, we already learned vertical angles, so let's actually do vertical angles first. So I'm going to say we have vertical angles. And if we look at our figure, we have vertical angles, and those are the angles that were formed by a pair of intersecting lines. They share a vertex, and they are opposite one another, and we learned that vertical angles are congruent. So vertical angles would be, let's start up here, would be like angles 1 and 4, or angles 2 and 3. So I'll say angle 1 is congruent to angle 4, angle 2 is congruent to angle 3, and then I have some more vertical angles down here. I can say angles 5 and 8 and 6 and 7. Angle 5 is congruent to angle 8, and angle 6 is congruent to angle 7. So this one's a review because we have done vertical angles previously. We could also do, we have learned adjacent angles or linear pairs. So we could also do those. So I'll say adjacent / linear pair. And those would be angles that are next to each other. So we could say measure of angle 1 plus measure of angle 2 adds to 180. Measure of angle 1 plus measure of angle 2 adds to 180 degrees. We could also say measure of angle 3 plus measure of angle 4 adds to 180 degrees. We can also look this way, measure of angle 1 plus measure of angle 3. So there are many that we could list here that are linear pairs. So I'm just going to put etc. But do know that we have looked at linear pairs or angles that are adjacent here. And so we could list those, and here they're adding to 180 degrees. Now we need to do the 4 new ones that we learned. So one of the ones that we learned, let's do alternate interior. So alternate interior angles, those are ones that are on opposite sides of my pink transversal, and they are smushed in the interior. So if you need to label your figure, you can. I would almost turn your page. Here would be our interior or inside, and then exterior or outside. So notice that our figure is turned. So those are our 3 different regions there. So alternate interior would be like angle 3 and 6. So we can say angle 3 is congruent to angle 6, or we could say angle 4 is congruent to angle 5. Instead of alternate interior, we have alternate exterior. And these ones are on opposite sides of my pink transversal, but now they're in the exterior region. So that would be like angle 1 and angle 8. Angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7. We have corresponding angles. And corresponding angles are on the same side of my pink transversal, and they're in a similar place in relation to each other. So same side of my pink transversal, and one would be interior region, one would be exterior region. So an example of this would be like angle 1 and angle 5. Angle 1 is congruent to angle 5. I could say, so I've got 1 and 5, I could say 2 and 6. Angle 2 is congruent to angle 6. I could say angle 3 is congruent to angle 7. I could say angle 4 is congruent to angle 8. So those would be all of my corresponding angles. There are 4 of them. And let's see, I think the very last type that I'm missing would be same side interior. Same side interior. And these are angles that are on the same side of my pink transversal, and they're smushed in the interior region. So that would be like angles 3 and 5. But be careful, angles 3 and 5 are not congruent. You can tell just by glancing at them. Here, angle 3 is a big obtuse angle, and angle 5 is a small acute angle. So these have a different relationship. Instead of being congruent, these angles are supplementary. So we could say that the measure of angle 3 plus the measure of angle 5 is equal to 180 degrees. And then there's one other same side interior pair, and that would be angles 4 and 6. So I could say that the measure of angle 4 plus the measure of angle 6 is equal to 180 degrees. So there are a lot of different types of special angles. We had previously learned about vertical angles and our adjacent linear pairs, but then today we learned 4 new special types. And a lot of the times you can look at the name, and the name will kind of give away what the relationship is between the angles, but these are terms that you will need to get to know in order to classify these angles. At this time, you have 2 different activities, or you could say 2 different U-tries, where you're going to need to use the figure to answer questions. So for the first one, it says, in the figure at the right, R is parallel to S. So our line R here is parallel to line S. So I'm putting the parallel arrows on the 2 lines. It tells us that the measure of angle 2 is 40 degrees. So I'll label that one as 40 degrees. And the measure of angle 4 is 60 degrees. And we need to find all the rest of the indicated measures. So my hint to you would be to come back and fill this in last. And first use your figure and label all of the angle measures on the figure using all of these types of special angle relationships. And then once you have your figure completely labeled, then go back and try to answer each of these. And then for your second activity, we are told that lines 3 and 4 are parallel, so you can add your parallel arrows here. Measure of angle 3 here is 2x minus 10. 2x minus 10. And the measure of angle 7 here, keep in mind angles 3 and 7 are not congruent. This is x plus 70. Again, we know they're not congruent because they are same side interior angles, or you can just glance. Angle 3 is a small acute angle. Angle 7 is a big obtuse angle. So we have an expression to represent each of those angles. And based on this figure and these expressions, you're going to have to find each of the other angle measures. So at this time, you're going to pause the video and see what you come up with for U-tries 2 and 3. So here's what I came up with, and this was a challenging U-try. The reason it was challenging is because you had 2 parallel lines and 2 separate transversals. So I highlighted one of my transversals in pink and one of them in blue. We were only given 2 angle measures to start, and so we had to use our knowledge about vertical angles, linear pairs, meaning, for example, right here, I can see that these 3 angles, angles 4, 5, and 6, have to add to 180 degrees. So let's say you knew angle 4 and angle 5. 60 plus 40 gives you 100. So then you would know this third angle would have to be 80 because all 3 of them have to add to 180. Or in other words, if you do 180 minus 60 minus 40, you would get 80. So you were having to use your knowledge then about all of these new special angle relationships in order to completely fill in your figure. So here were the measures that I had on my figure. And then once I had my figure completely labeled, you can double check over here that you do have all of the correct angle measures. For the second U-try, you had to write an equation. So I hinted to you that angle 3 and angle 7 were not congruent. One of them is an acute angle, one of them is an obtuse angle, and these are same side interior angles. So what we know about those is that they are supplementary, or they add to 180 degrees. So I added my 2 expressions, my expression for angle 3 plus my expression for angle 7, and I set it equal to 180 degrees. Then I was just solving a 1 variable equation. I combined like terms. I moved my constant over to the other side. I divided to get x by itself. And once I knew x was 40, I had to plug x back into each of these expressions so that I could find that the measure of angle 3 was 70 degrees and the measure of angle 7 was 110 degrees. So once you knew the measure of angle 3 and angle 7, then you were looking at the figure and you could label angle 3 and angle 7 with 70 degrees and 110 degrees. Then you were having to use the different special angle relationships that we talked about in order to find the rest of the angle measures by looking at your figure with your transversal cutting through your 2 parallel lines, which again gives you your special angle relationships.